hypervisor. The interesting thing here is they use the glue chips. How many of you know what the Q35 chipset for Intel does? DRAM controller controls the address iteration for DMA activity. So the idea is, of course, subvert the kernel, get a domain 0 kind of privilege by whatever exploits you can manage to get that kind of privilege. Then use the DMA controller to set arbitrary target address for your source address, and use the DMA transfer to move your code into the kernel, right? Into the hypervisor, actually owning access in the environment. Now, this is due to a flaw in the Q35 firmware. Intel has released the patch for that firmware, which was a prerequisite to Joanna releasing the rest of the documentation, the code, if you will, for how to exploit this thing. So to her credit and to Invisible Things' credit, they decided we're not releasing the exploit code until there's a patch out there for people to deal with, until it's been validated, and indeed that stuff has happened. However, what's the relevant security concern from an enterprise perspective? What do I need to know the impact of this in my environment, given I know there's a patch, and I know the version of the firmware that has the problem? What do I want to know? Where in my environment are those Q35s? What version of firmware do they have? And are they running something like Xen as a virtualization environment in the environment, right? When I know those things, I can make the right decisions with respect to security posture for the overall environment. But I need to know those very intimate configuration things to get there. This is just a little bit of detail on how it worked. By the way, the full paper that includes the source code and the complete description of the stuff over the last week or so since Intel released the firmware has now been posted at the Invisible Things lab site. It's called, I believe it is presentation 2, or part 2 of Owning Xen in the Owning Xen trilogy from BlackHat. So you can get it right off the internet and really understand this in all of its gory detail. Very interesting work. What's the impact of virtualization on security in general? Well, of course, it doesn't automatically create perfect security boundaries. And that's because the flaws in the underlying software. Now, where do those flaws come from? How many of you have written 100,000 lines of code in a single application? 300,000 lines. 750,000 lines. Okay, so Microsoft Hyper-V, 100,000 lines. Xen, 300,000 lines. How many of you believe those are going to be bug-free in the near future? So, what you don't get is perfect security boundaries. What you do get is very, very effective software that you can use if you control appropriately for emerging vulnerabilities when they occur. If you can put the right controls in place to deal with managing these assets, they deliver huge value. So you really want to do precisely that. The virtualization stack is a system. I have multiple virtualization levels. Nobody deploys server virtualization without also deploying storage virtualization. Why is that the case? When I vMotion an asset from here to here, does it need its file system? Oh yeah. So if I'm going to have the file system available when I vMotion this thing from one place to another, how nice to have an iSCSI-based SAN behind the scenes so that I can get at everything I need to get to. So I'm doing multiple layers of technology, all with their own configurations, all with their own vulnerabilities. I've got to manage this as a system. I cannot do the divide and conquer thing and manage each individual layer of technology in isolation. They aren't separable. They are actually indeed tightly coupled. Resource sharing in the stack creates some coupling and boundary conditions that we'll talk about in more detail, which is the primary focus of this presentation. And separately, virtualization security implies that you're going to be monitoring more controls, more layers of technology, and have more constraints than you ever had when you weren't virtualizing. It's just the heads-up comparison, and we'll make that more clear. That is the point of this presentation. So if I haven't touched that base by the time this presentation is over, you really ought to let me have it. Server virtualization is not the only kind of virtualization. We talked about storage virtualization lightly, but basically the idea is this. We have servers, we have storage. We understand how to deal with this part of the network, which is the internet and the LAN in our environment. But the storage network on the flip side of the fence, almost every problem we've ever had on the internet side in terms of spoofing, in terms of being able to do buffer overflows, in terms of being able to do stuff to compromise environments, has an analog that exists on the storage side of the network. So if you get Duaveri's book on securing storage, you'll get to delve into WWN spoofing and mutual authentication from either end of a host bus adapter out to an iSCSI SAN and all the stuff behind the scene. The real issue is when I deploy a new level of technology, I am deploying interdependent infrastructure that has configurations and has vulnerabilities, and we have to do something about it to effectively get the value out of the environment. These are more of the vulnerabilities, and these are the ones that are articulated, for instance, in the reference. Himanshu's book is just absolutely great in that it identifies the vulnerabilities, demonstrates how you can demonstrate the vulnerabilities are there, exploits if you will, and what to do about them in some very interesting ways. On the SAN side of the fence, where you have essentially a storage area network attached through usually iSCSI or fiber channel of one kind or another to be able to connect things together, there's some interesting effects, but it applies specifically to the transport protocols themselves. So we're hearing best practices emerge that essentially mandate doing mutual authentication on either side of the connection, being able, in some cases, to do encryption on those things in order to connect the root of trust all the way from the spindle back to the TPM module in the server. There's even more recommendations that are emerging. Some of these are showing up in regulatory mandates. So the Defense Department has a complete STIG about how do I configure the SAN with the 32 high-level controls that are the minimum required to use SANs in their environment. So we're even seeing it in the regulatory space. Application virtualization is almost as interesting in that we have in that circumstance an attempt to avoid DLL hell and collisions into registry entries, right? So the idea is this. I, on my end unit, sandbox the registry, sandbox the file system, sandbox the things that normally might collide when I have two applications fighting each other for the same settings, and instead give each application the view that it's got its own set of configuration out there. Now that's great, but what does it mean when I audit this end unit, this workstation that's sitting here that now has virtualized applications in its environment? Well, how many registries do I have to pay attention to? I've got the one the operating system sees in terms of the settings that affect its behavior, performance, security, and availability, but I now have a different one that the application is paying attention to, and depending on which application namespace I log into, those settings for this guy's registry may look significantly different than these. Which do I audit? When I get the NIST, CIS, SANS, or CERT checklist and I start looking through these things, I actually have to look at this guy's with respect to application behavior and security, and this guy's with respect to the operating system, and if I have 6 applications, well, I've got to do it multiple times, right? So what happens in application virtualization is that we've split to some extent by sandboxing and insulating applications from each other. We're forcing ourselves to audit more permutations of the context, which we rely on to determine did we indeed do what we needed to do in terms of configuration. But it doesn't get much simpler when I use the thinner forms of virtualization. So if I'm doing desktop streaming and I've decided, oh, I want all the configuration back on the server where it can deal with it with more sanity, I still have a place where the guy's web surfing here. If a rootkit gets installed, it's going to be here. Well, what happens to screen scraping in that environment? How much of what I see on the screen do I want on an IRC channel? God knows. So the awareness in virtualization, the ability to pay attention to how virtualization is articulated and what dependencies show up in the environment, and more importantly, where are the locus of assessment that I have to pay attention to in order to determine do I have a compliant/secure configuration, becomes just a little more complex. And in fact, in this circumstance, where I detect the problem, that is, I might audit an environment, see that the configuration settings are in the wrong place. Do I want to change those settings out on the endpoints? No. The locus of detection and the locus of fix are in 2 different spaces now, right? So I have a little bit more complex management problem to pay attention to as well. Network virtualization also is within the scope of things. And the interesting thing here is that when I virtualize networks, one of the things I'm doing is giving each guest operating system a virtual NIC. Kind of cool, right? More than that, they run faster than any real NIC because I'm going over a bus to communicate between these 2 guys. Really cool. But what does that mean for my network-based intrusion detection and intrusion prevention systems? How much of the traffic between these 2 guests is this external guy going to see? Not a lot. Can I do something about that? Absolutely. I can take the code that's here and inject it into the stack here and essentially have my mal-traffic detector sit on the IP stack inside the virtualization host. Is that a great idea? Well, it's a good idea at least, right? But what does it mean? When I have anti-spyware and anti-malware engines distributed across my environment, what do I do every so often? Update signatures, right? Now, where do I have to update additional signatures on every host that now has a stack that either has a whitelist, a blacklist, or heuristics to determine mal behavior? I now have another update problem. All this says is that when I do deep virtualization, I have more to do in configuration security posture and configuration